Think about speed for a second. We're talking about something moving at 800 meters per second. To the human eye, it's just a blur. But what if we could reach out and, well, grab it? Not with our hands, but with an invisible force. Let's see what happens when raw kinetic energy meets the world of magnetism.
There it is, stable, spinning, and seemingly unstoppable. But it's about to hit a wall it can't even see. Watch the sensors. We're locked in at full velocity, for now. Entering the tunnel. Those coils you see? They're creating a massive electromagnetic field. Right now, a physics phenomenon called Lenz's Law is kicking in. Think of it like the bullet is trying to run through deep water. The field is pushing back, creating tiny electrical storms inside the metal.
Look at the graph. That sharp dip, that's the moment the magnetic field says not so fast. We're literally watching an invisible tug of war between motion and magnetism.
Check this out. On the left, a weak field, barely a speed bump. But look at the right. That's 5 Tesla of raw power. The bullet is actually fighting for every inch. It's losing its momentum, and all that energy has to go somewhere. It turns into heat.
Do you see that faint red glow? The bullet is getting hot because it's working so hard to push through. It's even starting to wobble. The perfect flight we saw earlier, it's completely falling apart under the pressure of the field.
And just like that, the beast is tamed. From a supersonic projectile to a slow-moving piece of lead. We started at 800 meters per second, and we're exiting at barely a fraction of that. Magnetism isn't just for fridge notes, it's a universal brake system.
Soft landing. Experiment complete. It's amazing how a few copper coils and some electricity can rewrite the rules of motion. Physics is wild, isn't it? Catch you in the next experiment.